today, what we're going to discuss is viscosity, or with a Greek letter, small letter mu. No? So what is viscosity? So viscosity is the property of fluid which determines the amount of its resistance to shearing forces. So remember, yung ating first discussion yesterday, so yung unang part, sabi ko daw, kapag real fluid, no, there is resistance to shear. So that's why most fluids na ina-analyze natin here ay real fluid with Newtonian characteristics or Newtonian fluid. So a perfect fluid would have no viscosity. Of course, that's an ideal fluid. No, viscosity is the amount of resistance to shearing forces. When we say shearing forces, that is forces parallel, no? Parallel siya doon sa area of contact, no? From your set of materials. Okay, so example, let's consider this illustration. Actually, this is an illustration where we're going to derive, no, yung viscosity. So consider these two plates, no, with a small distance, no, yung height natin. So with a distance of y, no, then the space between them is filled with fluid. For example, yung pagitan nila may fluid yan. So we have the upper plate which is moving, no, may force applied on that. Then we have at a constant velocity of u, no, yung v dyan, no, let's take it na meron tayong velocity of u, no, considering na baguhin natin yung kanyang notation, no, may u at a constant velocity. So may velocity naman, yes, pero varying, di ba? Nakikita niyo yung blue, varying in velocity. But here we're going to consider that there's a constant velocity of u, no. The upper plate, no, the fluid in contact, no, in the upper plate will adhere, no, sabihin gagalaw siya at the same velocity. So ayan yun, no, given yung kanyang area, no, kanyang area of contact, height, then we have the force, no. We could have relations with that figure, no. Actually, it will came from your integral calculus and differential calculus, no. So first we have the relationship that the force is related to the area of contact, no, area ng plate times the velocity over the height, no. Meron silang relationships, no, merong proportionality, no, na tinatawag. So from there we could say that the force over area, no, yung applied force over the area is related or may relation to the velocity at a constant, no, constant velocity over the distance, no, of two plates, na yung height natin. So from there, if you still remember, no, if we're going to apply ng ating calculus part, no, so kasi pag fluid kasi, di ba, hindi mo naman siya makukuha lahat, no. You have to have a portion, no. That's why mag-differentiate tayo. We're going to find yung kanyang portion lang. So u over y, no, sabi ko nga kanina, base doon sa illustration, di ba, meron siyang varying velocity. So pwede natin sabihin na yung change ng velocity niya, yun yung constant velocity over the change in height, no. Yun yung ating consideration. Also, let's also consider yung shearing stress, no, from your strength of material. Actually, stresses are, general formula niya is force over area. So nagbabago lang yan, depende kung paano yung application ng force. Kung shearing force kapag parallel doon sa area of contact, 'di ba? So normal stress, 'di ba? Kapag perpendicular. So shearing stress, no, so F over A. So dahil nga may shear resistance to sa fluid. So consider natin 'yon. So pwede nating ipalit yan doon sa equation. Ayan. So let's say na yung force over area, pinalitan natin siya ng shear stress, the symbol na tau, is equal to dV over dy. Or pwede rin na meron siyang tau is equal to k dV over dy. That k is called the proportionality. No, proportionality, what we call the dynamic of absolute viscosity. So doon manggagaling yung mu, which leads to, ayan. So sabi dito, where the constant of proportionality k is called the dynamic of absolute viscosity, denoted as mu. So doon manggagaling yun. So therefore, pwede natin sabihin na from that equation, sige, balik mo tayo, yeah, so tingnan niyo mabuti ha. So from that relationship ng force, yung area of contact, then we have that constant velocity na galing doon sa varying velocity. Doon sa unang video, nakita niyo yon kanina. So dinerive natin, kumuha tayo ng kanyang, we take the derivative of that portion para magkaroon tayo ng ng portion lang na i-analyze. Dahil nga fluid ito, so malaking part lang siya, malaking part yun, so hindi naman natin ma-analyze lahat, so kasi varying. So we want a constant uh, so that we could apply the constant proportionality K on that. So we equate the tau, no, to the change in velocity over the change in height, which has that denoted natin as the viscosity or mu. So from there, pwede natin makuha yung equation ng viscosity as, or absolute viscosity from here. No? T is mu multiplied by the change in velocity over the change in height. No? From there, makuha natin yung formula ng mu. So that is tau over the change in velocity over change in height. So where tau, no, is shear stress in pound per feet square or Pascal, no, depende sa system na gagamitin natin, no, unit system. Then mu is the absolute viscosity, no, in pound second per feet square, or what to call poise. No, mamaya may papakita ko mga values, no, ano yung conversion ng mga poise to this unit, or Pascal second. No, yun ang kanyang unit, no. Then y, yung distance ng plates. No, pwede siyang feet, pwedeng meter, pwede rin millimeter, pwedeng centimeter. It's up to the kung sino yung mag-a-analyze or depending do sa problem na bibigay. Then yung u, no, that's a velocity, that's a constant velocity in feet per second or meter per second. So ayan yung formula ng ating viscosity. Actually, that's an absolute viscosity. No, mu is equal to tau or shear over the change in the velocity over the change in height, no, from those two plates, no, doon ang galing. Actually, kung meron lang talagang laboratory, makikita niyo actual, no. Hindi ko alam kung meron tayo dito sa TUP, but if meron, no, makikita niyo rin yun, na may parang may force na kung saan mahahatak yung tubig, no, parang mahihila siya. So kasi nga meron tayo tinatawag na shear stress or what we call yung resistance to shear. No, so ayan yun, no, yan yung kanyang formula. Doon din na-derive, no, yun yung ating derivation na formula for absolute viscosity. Okay? Sige. Next, if we have what we call absolute viscosity, actually that is dynamic of absolute viscosity. We have what we call also the kinematic viscosity or mu, yung kanyang symbol, small Greek letter mu. Okay? So, what is kinematic viscosity? So from the formula, no, makikita nyo dyan, actually kinematic viscosity is the ratio of dynamic viscosity of the fluid to its mass density. So, di ba, mu, yun yung ating absolute viscosity or dynamic viscosity. So, ratio siya ng dynamic viscosity or absolute viscosity or viscosity lang na tawag natin over the mass density. So, where, yan nga, yung mu, absolute viscosity, pag Pascal second, no, from the previous formula, then we have the mass density that is in kilogram per cubic meter. So, ayan yun, no, yung ating hahanapin. So, kapag meron ako ditong yung unit naman ng ating mga kinematic viscosity, actually, kinompare natin siya. Yeah, so, common units na ating mga viscosity. So, we have, no, kapag absolute viscosity, yung mu, usually kapag English, ang ginagamit natin, pound second per feet squared. No, bihira tayong gumagamit itong slug per feet second. No? Bihira yan, unless naka-state sa problem. Pero the usual that we use, kapag English system yung gagamitin natin, is pound second per feet squared. Okay? Kapag metric, no, kapag metric system ginagamit natin is 9 second per square centimeter. So, or poise, no? Mamaya, discuss natin ano yung mga specific value on that, no? May katumbas na value yan. Then, kapag SI, yung kanina, di ba, Pascal second yung ginagamit natin. Or, that is Newton second per square meter. Kasi di ba, ang Newton per square meter, di ba, force over area is, pressure or stress, di ba? That is Pascal. Kaya yun yung unit niya. Okay? So, just a sort of review. Yan yung ating unit for absolute viscosity. For kinematic viscosity naman, for mu, no, kapag English, kasi nga, di ba, from the formula, that is the ratio of what dynamic viscosity over the mass density. So, from the units, no, pwede nating makuha na ang unit ng ating mga kinematic viscosity kapag English is square foot over second. No, kapag metric, no, square centimeter over second, that is Stoke. No? Or kapag SI naman, square meter per second. So the usual kasi ng ginagamit natin, even here in the Philippines naman, we use SI unit. So, minsan may metric, minsan may English, pero the usual is SI. But depending do sa problem, sabi ko nga, if the problem requires you to convert your answer kahit na metric lahat or SI lahat yung given na units, pero the final answer wants you to convert it into English system, so you have to. Kaya meron tayong mga conversion dyan actually. No? So, eto, may ano ako dito, note ako dito. Ayan, so, 1 poise kanina, di-discuss natin, di ba? That is 1 dyne second per square centimeter. Okay? So yung 1 poise din is equal to 0.1 Pascal second. No, ito yung conversion niya kapag from metric to SI. No, ito na 'yon, no? So actually pakitandaan to, no, kasi yan, so magagamit niyo to sa actually we have some problems that we're going to use this one. So yung 1 dyne, 'di ba? Doon diyan sa poise, 'di ba? Ang 1 poise 1 dyne per 1 dyne second per square centimeter. Ang 1 dyne actually is equal to 10 raised to negative 5 Newton. No? Yun yung kanyang value. And 1 stoke, no, yung kanina diba napansin niyo, meron tayong stoke na value is 0.0001, 0.001 square meter per second. So ayan yung value niya. No, so class, no, remember this kasi most of the time some of the problems that you're going to encounter, no, sa fluid mechanics and even sa hydraulics, meron sila mga conversion na hindi na binabanggit. For example, find the kinematic viscosity, no, in terms of this unit, no, or absolute viscosity in terms of this unit. So ano na 'yon, interchangeable na 'yon. So hindi na binabanggit minsan sa problem yung mga given. No? Halimbawa, ito given na kasi ito eh. So minsan hindi na yung binabanggit, no, assuming na alam na nung sasagot or nung student na magsasagot ng exam. So ganyan 'yon. Okay? So please remember this, no? Don't worry, ito namang sabi ko nga, just like yesterday, yung ating lecture will be uploaded after this class, no, or discussion. So, okay, so ayan yung ating for mga viscosity. So, another property ng fluid that we have, actually, ito yung isa sa mga property na nakikita natin, no, in actual situation, is what we call surface tension, or we have what letter, small letter Greek sigma. No? Surface tension yan. Okay? The formula ng ating surface tension is rho, no? Actually, this is a pressure. No, actually, this is not a surface tension. Sige, balik mo tayo sa surface tension. Actually, yung surface tension is yung reason, no? Or parang yung reason behind bakit yung mga insects nakakatayo sila sa tubig. No? If you still remember that experiment on your high school, so di ba may mga parang may experiment about surface tension? Because surface tension is an intermolecular cohesive forces. No? Yun yung nagkakakos ng bubbles. No? Kaya merong na insect nakakalutang sila sa tubig, di ba? Minsan, no, may mga ganong instances. So, ang formula natin, itong formula na to, na pinakita ko na kanina, actually, this is a formula of a pressure inside the droplet of liquid. No, that is 4 sigma over the diameter. Okay, where P is the gauge pressure in Pascal. Gauge pressure to, no, yung P na to. Hinahanap natin. Diba? Kasi last time, no, in our discussion yesterday, discussion natin ng mass density or ng ibang property ng fluid, we are using what? Absolute pressure. Tama? So this time, in surface tension, what we're going to use is a gauge pressure. So kaya kapag ang given absolute tapos binigyan ka ng atmospheric pressure, isubtract mo na lang, no? Kasi 'di ba, ang formula ng absolute pressure is gauge pressure plus atmospheric pressure. Remember that yesterday sa sa problems and even dun sa ating discussion. So kapag dito sa surface tension na problems, gauge pressure yung ating ginagamit. That is in Pascal. Okay? So the diameter of droplet in meter, pwede rin siyang given na millimeter, depende sa binigay na situation, and sigma is the surface tension in Newton per meter. So, ayan, no, yan yung ating formula for surface tension. No? Actually, ano yan, formula yan sa pressure inside a droplet of a liquid. No? Doon kasi yun, di ba, kapag kung saan nakakatayo yung mga insect, diba, nagpo-form siya ng parang bubbles. So, ayan yun, no? Yung pressure sa loob nun, na merong application of surface tension. Okay? Sige. So from there, pwede nyo naman ma-arrive, no, diretso, yung surface tension formula. No? So, di ba, i-transpose nyo na sa kabila, that is pressure, di ba, pressure multiplied by the diameter over 4. Di ba? PD over 4. So yun na yun. So yun yung formula ng surface tension. Pero ito, specific to for the pressure inside ng droplet of a liquid. No, that causes yung yun nga, yung may mga lumulutang, floating objects na because of surface tension. Okay? Sige. Ayan yun. So, next we have what we call the capillarity or under kasi ito sa surface tension, we have what we call the capillary or capillary action or capillarity. Actually, capillarity is the behavior of the liquid in a thin bore tube. Most of the time, this capillary, no, yung tube niya is smaller than about 3/8 of an inch or 9.5 millimeter. So, sobrang less than a centimeter. Kaya usually nangyayari itong mga capillary action or capillarity in a thin bore tube, sobrang ninipis. No? Kapag sa mga laboratory, so kung dati kung kayo sa mga laboratories niyo before, kung high school kayo, kung na-experience niyo mga test tube na maliliit, di ba? Maliliit yung kanyang butas. So, nagkakaroon doon ng mga capillary action. So, ang formula natin for that, no, sa capillarity, actually, is the height, no, nung water, no, from yung sa sa yung tubig sa tube. That is 4 sigma cosine theta, ayan, over, gamma d. So, alam natin yan kapag yung sigma, surface tension, yung theta dyan, that is the angle, no, na kung saan yung angle of contact between the water and the wall ng tube. So, gamma, unit weight. Okay? So, kapag complete wetting naman, so, kapag complete wetting, as with the water on clean glass, no, the angle theta is 0. Ibig sabihin puno, no, or parang nakapantay. Di ba pa naglalagay tayo ng tube sa test tube, minsan may parang parang curve. No? Ito naman, kapag complete wetting, sabihin basa lahat yung surface ng glass, no? So, yung angle theta natin is 0. So, pwede natin sabihin na yung height ng water or ng capillary, actually, that is the height of the capillary, is 4 sigma over gamma d. No? So, kasi di ba ang cosine theta, cosine 0 is 1. Okay? So, yun nga, H is a capillary rise or depression. So, yun yung capillary or capillarity, no? So, yung H. Pwede siyang rise if that is positive, no, depende sa angle na given, then depression, no, kapag depende rin sa angle na given. So that is meter, no, pwede rin millimeter yan depending upon dun sa binibigay or hinihingi ng problem. So gamma is the unit weight in Newton per cubic meter. So the diameter of the tube in meter, so pwede rin siyang millimeter, no, kasi di ba usually as I've discussed, no, these are capillary action or capillarity are usually seen sa mga thin bore tubes or yung mga maliliit na tubes. No, then sigma is the surface tension in pastime. So ayan yun, no, yung ating formula. So that is for capillarity or what we call capillary action. Okay? So meron tayo dito, no, since we're talking about yung mga angles, no, yung sa tubes, no, sa mga tubes. Yeah. So meron tayong mga contact angles na theta na given na. The usual materials that we use sa mga laboratory, sa mga testing centers, diba? The usual, meron yung if you want to know yung ating capillary, diba? So computation natin sa part na yon. So meron na. So given yan. Kapag mercury glass, that is 140 degrees. So kapag water paraffin, no, yung ating contact angle, that is 107 degrees. Kapag water silver, 90 degrees yon. Kapag kerosene glass, 26 degrees. Kapag glycerin glass, 19 degrees. Kapag water glass, tsaka ethyl alcohol glass, 0 degrees. So, ayan, no? Actually, ito naman, no, kahit hindi nyo to i-memorize, kasi usually naman, depende yan sa given. No? Nag-iiba-iba yan, no? Pwedeng iba, other than this material. Pero ito yung mga commonly used na ginagamit natin actually, no? Kung may laboratory lang talaga tayo. So, ito yung mga commonly used na ginagamit. So, they have their specific na contact angles. Actually, these angles is hindi naman yung eksakto, no? May mga discrepancy yan, depende yan sa test, no? 140.002 or 140.003, mga something like that, no? So, of course, lang natin, round up natin to the whole number so that we could easily analyze, no? Kasi sobrang liliit lang din naman, okay, ng mga discrepancy. So, ayan yung mga values nun. So, okay, sige, next. We have another property, no, what we call compressibility. So when we say compressibility, it is the fractional change in the volume. Sige. Actually, yan. This is a fractional change in the volume or of a fluid, no, per unit change in pressure in a constant temperature process. Actually, that is what we call, or also known as coefficient of compressibility, yung beta, no? That is yung symbol, di ba kanina? So, from there, no, from that definition, pwede natin sabihin ito. Ayan, so, ayan, sumobra. So, sabi dito, change in volume of fluid, no, per unit, no, to the constant, to the change in pressure at a constant temperature. Kaya wala ng temperature dyan. So, negative yan kasi the usual naman is pa-decrease, no, yung ating compressibility kasi kino-compress mo, pinapalit mo. So, negative change in velocity over the velocity yan. So, over delta P. So, from there, makakuha natin yan. So, using calculus, diba? So, negative change in velocity over the velocity over change in pressure. So, that is, or pwede natin sabihin din yan, no, yung ating compressibility, I'm connected siya sa ating susunod na property, which is mamaya, discuss natin ito further, which is bulk modulus of elasticity. Or modulus of elasticity. Maybe yan kasi bulk modulus, kasi di ba fluid, discuss natin. That is beta is equal to 1 over bulk modulus of elasticity. So later, mamaya discuss natin further yung bulk modulus of elasticity. Pero ito yung kanilang relationships. No? So pwede nyo gamitin to. No? Ibig sabihin, yung bulk modulus of elasticity multiplied by the compressibility is equal to 1. Diba? So yun yun. Okay? So ayan yung kanyang value. So ayan yung kanyang formulas. So sabi dito, yun nga, delta V change in volume, V original volume, then delta P is the change in pressure. Tapos yung dV over V, yung kanina, 'di ba? So that is change in volume usually in percent. No, kaya 'di ba negative, pag negative yan, decreasing yung percent na yon. So ayan yon, yun yung mga given do sa formula. So doon sa formula, napansin nyo rin nga, di ba, merong kasama siya na E sub B or what we call, sige, punta na tayo sa next, or what we call the bulk modulus of elasticity. I know you already heard this modulus of elasticity from your strength of materials, right? So, we're analyzing the bulk, yung bulk. No, pag sabi ko bulk, bultuhan, di ba? Sa Tagalog, bultuhan yun. Kasi nga, what we're going to analyze here are fluid. Hindi naman kasi na napipira-piras yung fluid, 'di ba? So bultuhan talaga siya. And you cannot, kaya nga may portion kanina sa ating yung mga unang properties that we need to derive, no, sa viscosity. We have to find a strip, no, or kumuha tayo ng strip para ma-analyze natin yung viscosity, makuha natin siya. So the same thing with bulk modulus of elasticity. So this bulk modulus of elasticity of fluid expresses the compressibility of fluid. So kaya may kinalaman siya doon sa compressibility yung kanina. So it is the ratio in the change in unit pressure to the corresponding volume change per unit of volume. So ito yun siya. Yan. So ayan yun, nabanggit ko na kanina. Sa formula, that is stress over strain. So if you remember the formula of modulus of elasticity dun sa inyong strength of materials, that is stress over strain. No? That is, no, that because it is stress over strain, so pwede natin sabihin na that is the change in the pressure, no, kasi stress over the change in volume per volume. So strain, di ba? Ang strain kasi is dimensionless unit, di ba? So, or not dimensionless unit, but the unit of strain is meter per meter, di ba? From your set of materials. So hindi siya dimensionless pala. Sorry, it is may unit siya meter per meter. So ayan yun, di ba? Stress over strain. So yan yung kanyang formula for bulk modulus of elasticity. And that is negative, no? Bakit negative? Dahil nga may kinalaman niya sa ating compressibility. So kanina napansin nyo sa compressibility, negative din, no? Negative. Why? Dahil decrease lagi yung nangyayari yon, percentage decrease, no? Kasi kino-compress mo nga, no? So ayun yung idea doon. Bakit siya negative? No? Yun yung parang basic principle behind that. Okay, so that is the formula for, or that is the property of fluid, what we call the bulk modulus of elasticity. Actually, it's almost the same with the modulus of elasticity in your strength of materials. No? It just so happen na ito ay ginagamitan natin ng fluid naman to analyze. Hindi siya yung the usual materials na ginagamit. No? Fluid na ginagamit, hindi siya solid. Okay, next, we have the Ayan, pressure disturbances. Actually, these pressure disturbances impose on a fluid move in waves. So, sabihin siya, may kinalaman to dun sa velocity or what we call yung kanyang paggalaw, no? Sige, tingnan natin yung definition niya, further definition yan. So, yan nga. So, disturbances imposed on a fluid move in waves, no? Yung velocity or what we call the celerity of pressure wave, ayan yung i-analyze natin ngayon. Also known as acoustical speed. So, ito yung kanyang formula. Actually, this is the one na hinahanap natin, yung celerity. No? Celerity is equal to, yan, the square root of bulk modulus of elasticity over mass density. So, ayan yun, no, hinahanap natin. Or, pwede rin siya the square root of 1 over compressibility multiplied by the mass density. Kasi di ba yung ating, you still remember yung kanina, di ba? Yung ating bulk modulus of elasticity is equal to 1 over compressibility, or compressibility is equal to 1 over bulk modulus of elasticity. So, ayan, no? Kaya pwedeng maging ganyan. Either of the two, yun yung hinagan. Yung C dyan is celerity, no? That is the celerity of pressure wave. Usually, ang unit niyan, no, since velocity yan, meter per second. Okay? Sige. Yan yung hinahap natin. Usually yan nangyayari ang kapag, for example, no, ang one of the best example niya, nag-a-analyze tayo ng yung deep sa ocean, kung gaano kalalim, yung mga parang ina-analyze natin kung hanggang saan yung kanyang seabed, mga ganun. So, gumagamit tayo ng mga sonar, no, yung mga parang mga equipment. So, ginagamitan niya ng itong principle na to, no, ng pressure disturbances. Kasi, di ba, gumagamit tayo ng sonic waves, no, to measure. So, ayan yun, no, dyan natin nakukuha. Actually, ito yung principle behind it. Paano nila nalalaman yung height, no, or yung parang kung gaano kalalim, no, from that celerity of pressure wave. Okay? Sige. Next, we have the property changes in ideal gas. I know, no, some of you medyo may idea kayo when it comes to ideal gas. When you say ideal gas, ito yung mga gases na usually na-analyze ng mga previous scientists, no? So, ito ay first equation na papakita ko sa inyo. Actually, you know this, no? For any ideal gas experiencing any process, so that means may temperature, may pressure, may volume, ay, tama ba? Pressure, temperature, and volume, yes. So, ito yon. So, P1 V1 over T1 is equal to P2 V2 over T2. This is a combined gas law, remember? No, from your physics, di ba? So, this is a combined gas law. So, dahil lahat sila merong change in temperature, di ba? T1 is the initial temperature, T2 final temperature. The same thing with pressure, P1 is pressure. So, pag 1 initial, pag 2 final. So, sa volume, ganun din. Pag 1 initial, pag 2 final volume na yon. So, ayan. So, yan yung ating combined gas. Ngayon, kapag yung temperature naman niya constant, so remember the Boyle's law, yung ating Boyle's law, that is P1 V1 is equal to P2 V2. Ayan yon. So, kapag temperature naman niya constant, no, just a sort of review, no, ayan yon yung gagamitin natin na formula. So, remember that on your physics. So, yan yon yung gas, yung mga gas law. So, Boyle's law yung gagamitin natin that during kapag ganyan yung ating set, no, kapag constant temperature. Ngayon naman, kapag yung pressure naman yung constant, ayan. So that is V1 T1 so to V2 T2. Ayan. So ayan yun, no, constant yung pressure. So ang tawag diyan yung Charles law or what we call the isothermal condition. No, kasi may change in what? Temperature. No, isothermal yung condition. So ayan yun, no, Charles law yung ginagamit natin. So, okay? So, ano yun parang review lang yun, no? Sort of review ng inyong mga previous na topics sa physics. Pero ito, additional, no? Para additional, I don't know kung na-discuss sa inyo to sa physics part niyo because when you say naman, di ba kanina isothermic yun yung ating condition. So, for adiabatic or isentropic naman na condition, so there's no heat exchange, no, walang heat exchange, no, from one yung gases natin, no? So yung gagamitin pa rin natin yung kanina na formula, yung P1 V1 so to P2 V2 na Boyle's law, but we're going to include this K, no? That K is the ratio of specific heat at a constant pressure. So ayan yun, no? Ginagamit natin yan to the specific heat at a constant volume. It also known as adiabatic exponent. Kaya nga adiabatic condition. So meron na siyang adiabatic exponent. Actually given yan. So wala yung dimension. Ay wala yung wala siyang dimension. So dimensionless yan. So K 1.5, 1.3 depending dun sa gas. So pag adiabatic or isentropic din, so yung formula pwede natin masabi na kapag tinranspose natin from one equation or from left side to right side of palitan sila, so pwede sabihin na V1 over V2 raised to K, no, or yung ating adiabatic exponent is equal to P2 over P1. So that is a constant, no? Constant kasi yan. So constant yung kanyang parang temperature, walang temperature change, no? Pero kung may temperature change naman, ayan, kasi kahit na may temperature change, minsan no heat exchange pa rin yan. So T2 over T1, so yung galing yan dun sa natin, dun sa formula, dun sa Charles law naman, no? So yung ating I mean galing yan doon sa combined gas law, pero tinanggal na natin kasi yung volume niya yun naman yung naging constant. Pero yung adiabatic exponent niya, so iba doon, hindi lang siya K, that is K minus 1 over K. Ayan. So ito yun, no, kapag isentropic condition. The usual kasi na pinag-aralan natin before are all isothermic, no, may heat exchange. Kaya nga we're discussing about Charles law, Boyle's law, the combined gas law. Kasi siya, isothermic yung kanyang condition, no? Isothermal condition. So ito naman, adiabatic or isentropic condition. So kaya yan, meron tayong tinatawag na adiabatic exponent. So ayan yun, no? Yung ating for ating mga property changes in ideal gas. Okay?